Hello everyone. In this class we are going to discuss about numerical methods. I am Dr. Vishma George, Assistant Professor, Department of Mathematics, PSN College of Engineering and Technology. Here we will discuss what are the learning goals and introduction, Gaussian methods, Gaussian procedure, then some exercises, resources, some references. Learning goals, learning object in this model, develop problem solving skill using computer and numerical methods, review the Gaussian elimination method for solving simultaneous linear equations, develop program skills using Fortran. So new Fortran element in this modulus. Okay. Let us see what is matrix. And matrix is a m by n rectangular array which contain the elements arranged in row column ways, that is A11, A12, A13, A13 etc. up to Amn. Here Mn is a positive integer. Each entry in this matrix is Aij. Terminology. A real matrix is a matrix of all whose entries are real numbers. Here I is called the row subscript and m by n matrix is said to be a size of m by n. If m equal to n, the matrix is square of order n. If m equal to n, then the Aii are the diagonal entries. Augmented matrix for a system of equation. Given a system of equation, we can talk about its coefficient matrix and its augmented matrix. To solve the system, we can now use row operation instead of equation operation to put the augmented matrix in row echelon form. Row echelon form. A matrix is in row echelon form if the lower left quadrant of a matrix has all zero entries. In each row that is not all zeros, the first entry is a 1. The diagonal element of the coefficient matrix are all 1. Here the Gauss elimination method was introduced by Carl Friedrich Gauss, a German mathematician and astronomer in early 19th century. So in this method, Gauss elimination method, the operation in this method are called the elementary operations. Elementary operations for row are interchange of two rows, multiplication of a row by a non-zero constant, addition of a constant, multiple of one row to another row. Two matrices are said to be row equivalent if one matrix can be obtained from the another using row elementary operation. Gauss elimination for solving a system of equation. First we need to write the augmented matrix for a given system of equation, then use elementary row operation to construct a row equivalent matrix in row echelon form. Then we will evaluate the row echelon form. Using the back substitution, we get the solution for the variables x, y, z. For a 2 by 2 matrix we get x and y. For a 3 by 3 matrix we get x, y and z. So Gauss elimination method. Let me see the example. Let us consider the set of linearly independent equation 2x minus 4y plus 5z equal to 36 minus 3x plus 5y plus 7z equal to 7. 5x plus 3y minus 86 equal to minus 31. Augmented matrix for the set is 2, minus 4, 5, 36. Here we write the coefficient for a first equation. Then in second row we write the coefficient of second equation, that is minus 3, 5, 7, 7. Then we write the third equation coefficients are 5, 3, minus 8, 31. So we need to convert this matrix into row echelon form. So here we using the coefficient of first row. Let's see, this is the coefficient of x, this is the coefficient of y, this is the coefficient of z, this is a constant. Okay, so we need to change these two terms to convert into 0. So first using the second equation minus 3, converting this into 0 using the first operation, first row. So in R2 what we get in, if we use we will only convert minus 3 into 0, we need to add some 3. So here first row we have 2, so dividing 2 then multiplying with 3. So add with R2, what we get? 3 by 2 R1, 3 by 2 R1. That we check this, first element is minus 3. So using minus first row R1, here we have R1 2. So dividing R1 by 2. So here we get 1. Then multiplying with 3. Then add with minus 3 we get here 0. So same operation we need to apply for each and every element in this matrix. So we get 0, minus 1, 14.5, 61. Here the operation R2 dash is we get from multiplying 3 by 2 with R1 and add with R2. Okay. Then in next second equation, third equation, here also we need to convert this x into 0. So multiply, here the coefficient is 2. So we need to change this as 1. So dividing with 2. Dividing R1 with 2. So we get here 1. Okay. Then multiply with 5. So what we get? Minus 5 by 2 R1 add with R3. So we get 0 here. 5 will cancel out. Then here is 1. So the answer is 0. 0. Apply the same condition for each another terms also. Look here. In this element we get, how will we get? Multiply 3 with minus 5 by 2. Multiply minus 4 with minus 5 by 2. Okay, then add with 3. So we get 13. Similarly here also multiply minus 5 by 2 into 5 and add with minus 8. So here we get minus 20.5. Here also multiply minus 5 by 2 into 36. Okay, minus 5 by 2 into 36, then add with minus 31. So totally we get minus 121. Here the transformation of equation. So in next step, in step 2 we need to convert this third equation, y coefficient should be 0. Here see this is the principal diagonal element. Here the lower triangular. This is of the form is triangular, right? 0, 0, 0. This is these two are x coefficient. These are y coefficient. Okay, so how will you get this? We need to use the first row. Check here. Here we have 13. Okay, so we need to convert 13 into 0. So using first row. First row we need to, no need to add first row. Why? Because we already converted these two terms as 0. So if we use the first row, we not able to convert this as again 0. Okay, so no, don't use first row. Use the second row, then convert this 13, convert to 0 because 13 into R2. Okay, multiply R2 with 13, then add with R3. So we get 0, 0, 168, 672. In third step, what we need to find out? Here we get the row echelon form. So using the back substitution, okay, we are going to using back substitution. Here we see 168. This is the coefficient of z is 168. The variable is 672. Okay, so we are dividing this row with 168. So we reduce the value of the coefficient of z. So we get 1. Here 168 divided by 68 we get 1. 672 divided by 168 we get 4. Okay, so the coefficient of z equal to 4. We get the value of z. Substitute the z value in second equation. What we get? Here write this as equation y. Check this. In the first equation we get x minus 2y plus 2.5 z equal to 18. In second equation what we have? Y minus 14.5 z equal to minus 61. Look here, third equation what we have? Z equal to 4. So substitute the z value in the second equation. What we get? Y minus 14.5 into, substitute the value of z is 4. So we get the value y equal to, what we get the value? Look here, y minus 14.5 z. We get the value y is minus 3. Okay, in a first row so we get the value of z and the value of y. Substituting both these two values in first equation, what we get? X minus 2y plus 2.5 z. Look here, this is the coefficient of x, this is the coefficient of y, this is the coefficient of z. So x minus 2y plus 2.5 z equal to 18. Okay, we have the value z equal to 4. Substitute the value of z, substitute the value of y in minus 3. So we get the value x equal to, simplifying this row. Okay, here look here, x minus 2 into the value of y is minus 3 plus 2.55, the value of z is 4. So we get the value, simplify these two terms. First we need to multiply these two terms. So minus into minus plus, 2 3s are 6, then multiply with 4 with 2.55, then add these two terms and move this to another side. So we get the value x equal to 2. Okay, let's check the second example. When would you interchange two equations? What will happen? Okay, look here, using this equation. Check here, first equation. Let us consider the following set of equations. Look here, 3y plus 2 is equal to 16. Second equation, 4x plus 2y minus 3 is equal to minus 10. Third equation, look here, 3x plus 4y plus is equal to 9. In three equations, check the coefficient of first equation. Here we have 0. So if we have the first element as 0, we are not able to convert the row echelon form for given equation. So we are interchanging the rows. Okay, cannot be used to eliminate x from the equation 2 and 3. Okay, so interchanging the row 1 and row 2. So the augmented matrix is 4, 2, minus 3, minus 10, 0, 3, 2, 16. Okay. In the third equation, 3, 4, 1, 9. Okay. Now we are going to follow the steps for Gauss elimination method. What are the steps? First we need to convert first we need to write the augmented matrix, then we converted it into echelon form. Then by using back substitution we will evaluate the value of x, y and z. Okay, we are already discussed the method. Okay, so using that method we need to convert these two elements as 0. Okay, already we have 0, so we no need to change this as again. So using third equation only we convert 3 as 0. How will you change this as 0? First divide with the first row R1. Using R1, divide R1 by 4, then multiply with 3. So we have 3. So subtract with R3 minus R1. What we get here? We get 0. Using same operation apply for every elements. It's in third row. Okay. So we get what we get. We will convert this into these x2 coefficients are 0. Then again using second equation, we no need to use the first equation. Okay, use the second equation, then convert the 4 into 0. Okay, here we know we get another value because we already operate with first equation and third equation. So here will we get another value. So convert using this row, use the coefficient of y value. Okay, use the coefficient of y value, then change this as 0. Okay, so we get 0 first second equation and third equation. The x coefficient will be 0. In the third equation we get the y coefficient will be 0. Okay, use the same operation for remaining 1, 9. So here the values will be changed. So below the diagonal the matrix converted into upper triangular matrix. Okay, so then the third step what we do? Using back substitution. Okay, equating the coefficient of z, here we get the value of z. Coefficient of z equal to, here we get some value, so we get the z value. Substitute the z value in the second equation. What we get? We get the value of y. Okay, so we get the value of z and the value of y. Substitute these two values in equation number 1. What we get? We get the value of x. So the solution will be x equal to -3, y equal to 4, z equal to 2. Okay. Here the applications. Gauss elimination has numerous applications in various fields like physics, finding the trajectory of a projectile. Okay. In engineering, circuit analysis, fractal analysis. Okay. In a computer science, e.g. computer graphics, machine learning. Okay. In economics, econometrics, resources allocation. Okay, resource allocation. Here also we use the numerical method. Okay, particularly we use the Gauss elimination method. Okay, then we are going to discuss about Gauss-Jordan elimination method. The same concept. This is some updated from Gauss elimination method. Okay, here we are convert the given augmented matrix into identity matrix. That is, the diagonal element will be 1. The remaining element will be 0. Here check. In Gauss elimination method, we continue the reduction of the augmented matrix until we get a row equivalent matrix in reduced row echelon form. Okay, reduced row echelon form. Check. Here the principal diagonal element is 1. Remaining elements are 0. Okay. The Gauss elimination method. Let us consider one example. Okay. 2x minus 4y plus 5z equal to 36. In the second equation, minus 3x plus 5y plus 7z equal to 7. In the third equation, 5x plus 3y minus 8z equal to minus 31. First we need to write the coefficient into the augmented matrix. That is 2 minus 4, 5, 36. Minus 3, 5, 7, 7. Okay. Check here. 5 3 minus 8, 31. 5, 3 minus 31. Okay. This is the coefficient of x. This is the coefficient of y. This is the coefficient of z. This is constant. Okay. Okay. In Gauss-Jordan elimination, first we convert this into upper triangular matrix. Okay. So already we discussed in a Gauss elimination method, we are using the first row to convert these two elements to 0, right? So using first equation 2 minus 4, 5, 36, then convert this first element as 0, then again convert this as 0 using the first row. Then after that what we do? We will use the second equation to eliminate or convert 0 the coefficient of y in third equation. Okay, check here. Here what we get? Already same equation only discussed for Gauss elimination method, but we are going to solve the same equation with Gauss-Jordan method. Okay, here the coefficient of y is 13. So adding with the R2 with multiply 13 and add with R3. What we get here? We get 0. Okay. So we convert the given matrix into upper triangular matrix. After that we are going to change the principal diagonal element to 1. Okay. So here check 0.5 R1. Here we are dividing 168 R3. We are dividing by 168. So we get 1. Okay. Here we have minus 1. In this row we have minus 1. So multiplying with minus 1. So we get plus 1. In the first equation we are dividing by 0.5. Okay. So finally we get into the form of z value, then substituting z value now. Here the coefficient of z equal to 4. Okay. In a elimination method we use the back substitution to evaluate the values, but here in a Gauss-Jordan method we are again operating the same operation for convert this as identity matrix. So here using the third row to convert these two elements as 0. Okay. So using the R3. Okay. Using R3 we are multiplying 1 with 14.5. So add with this, what we get? Here we get 0. Okay. Again we are using, we don't use the third row, use the second row to change this to 0. Okay. So these two elements, these already we used the third row to change this to 0, this to 0. Okay. Now finally we use the last row to convert this to 0. Okay. Check here. Here we are converting this to 0. In R2, R1 we are already, we have 0, 0, 1, 4. In a second row we have 0, 1, 0, minus 3. Okay. In the first row, what we are going to do? We need to change these two elements, right? So changing first this element as 0. So using which row? Using the row 2. Using the R2, multiplying with 2, then adding here. So we get here 0. Okay. So finally we need to change the 2.5, the coefficient of first equation z. This is the coefficient of x, y, z. So need to change the third value of z. So converting R3, using the R3, multiplying with 2.5. So we get 0, 0, 2.5, 1, right? So add with this, we get 1, 0, 0, 2, 0, 1, 0, minus 3, 0, 0, 1, 4. Okay. So finally we get the value of x equal to 2, y equal to -3, z equal to 4. Okay. These are the references. Okay. Numerical recipes in Fortran, Cambridge University Press. Reference of textbooks. Okay. Check here. The textbook also accessible online. Okay. Check here. These are the resources, website pages, numerical recipes, Fortran tutorials, professional programmer guide to Fortran, 77 programming Fortran. Okay, thank you.